Okay, so welcome to our laboratory extension of Regents Chemistry, and this is laboratory activity 1.1, where we talk about the qualitative analysis of density. Okay, and so our major understanding for today is that elements can be differentiated, or pure substances, because pure substances, including compounds, can also be differentiated by their physical properties, and their physical properties or the physical properties of substances such as density, conductivity, malleability, solubility, and hardness differ among elements. Okay, and so today we're just going to focus on density, and we're going to focus on qualitative or relative density. Okay, and so density is the quantity of mass contained in a specific volume. Okay, and the units we're going to use for density are grams to represent mass, and milliliters or centimeters cubed to represent volume. So the amount of mass in grams contained within 1 milliliter, or the amount of mass in grams contained in 1 centimeter cubed space. Okay. And so it's very helpful to refer to our New York State chemistry reference table for this lesson, and specifically table S, which has densities for some of the elements in the periodic table. Okay, and so if you look on table S, the elements are arranged according to atomic number. Okay, and today we're just going to focus on the element lithium. Okay, and so lithium is the third element down, so I'm just going to start off with the first 3 elements on table S. So atomic number 1, atomic number 2, and atomic number 3. Okay, and so they also give you the symbol. Okay, and so the symbol for the element with atomic number 1 is hydrogen. Atomic number 2 would be helium, and then atomic number 3 would be lithium. Okay, and then if you go further over on the table, skipping some of the columns, you'll come to a column that says density in grams per centimeter cubed. Okay, and if you go down and look at this value for lithium, you'll find that lithium has a density of 0.534 grams over centimeters cubed. Okay. Now, in our graduated cylinder, we have 3 pure substances. We have solid lithium. Okay, so the parentheses S is telling us that our lithium is in the solid state. Then we have mineral oil, which is liquid. That's what the parentheses cursive L means. And then we have air, which is in the gaseous state. Okay, represented by a lowercase g in parentheses. Okay, so we know that our density for lithium, according to table S, has a density of 0.534 grams over centimeters cubed. And now we can use that information to determine the relative density of both mineral oil and air. Okay. Now, the rule is that something that's less dense will float on something that's more dense. So because of that, we know that the density of mineral oil, so we know that mineral oil's density must be greater than the density of lithium. Okay, And this works for any density column. The substances that have a greater density will be found on the lower portion of the column, okay? And if we look up the density of mineral oil, it will not appear in table S, but we can look it up in a textbook or on the internet. You'll find that it has a density of 0.830 grams per centimeter cubed. Okay, which is greater than the density of lithium of 0.534 grams per centimeter cubed. Okay. Now the same thing will work for air, since air is positioned above lithium and mineral oil on the column, then we know that the density of air must be less than both. Okay, but specifically it must be less than lithium. Okay, so density must be less than the density of lithium. Okay. And if we look up the density of air, also not going to appear in our New York State chemistry reference tables because not an element, but it'll have a density of 0.0013 grams per centimeter cubed. Okay, and so the general rule here is that if you have a density column, the substances that are less dense will appear above or at the higher end of our density column. And as you go down your density column towards the bottom, you'll have things that are more dense. Okay, and so that is our first lesson on density. The next lesson, we'll start talking about quantitative analysis of density, or calculating the density given the mass and volume of a substance. And that's it. So I'll see you for lesson 2.